Good evening to all the learners and academic counselor, Ms. Pavan Kumari. I welcome you all for fourth day MBA counseling sessions. I think today onward she is going to take the new course MMPC 003. I hope, or quantitative techniques, quantitative analysis. That is, I think, 5. I hope you all have learned something from the previous academic counseling sessions conducted by Ms. Pavan Kumari. And now I hope you are all going to get the more knowledge on this coming 2 more days. Today, tomorrow, and day after tomorrow, going to be completed for these 3 sessions. I request you all the students, please join and attend the sessions sincerely. IGNOU Regional Center Visakhapatnam is conducting these sessions for the benefit of the students. I am again reiterating that if the student attendance is not that much, then we are not going to conduct the sessions. Because of MBA, we are having more than the 80 students, but the student percentage attendance is very less. It is a waste of the time and the money also. That's why I request you all inform to your friends also to attend. But however, for the benefit of the learners, recorded videos we are uploading in our RC Visakhapatnam YouTube channel. Later also you can watch and view the recorded videos and gain the knowledge. I wish you all the best. Thank you one and all. Ms. Pavan Kumari, please take the session.
Thank you, sir. Thank you. Good evening, everyone. So today we are going to discuss about quantitative analysis for managerial decisions or managerial applications. First, let me share the screen first. So I think screen is visible to everyone. Okay. So today's subject is MMPC 05, Quantitative Analysis for Managerial Applications. So what is quantitative analysis and why we have to use these particular techniques in a business? Actually, quantitative analysis or quantitative techniques are, it is a combination of mathematics and statistical tools. Okay, we are combining these both tools, that means mathematical procedures as well as statistical tools. And why we are using these particular mathematical tools and statistical tools means for analyzing the quantitative data which will be obtained from the business operations, so that we can take effective decisions in that particular business. Okay, because in business daily we are doing some transactions for maintaining that operations in a business level, right? So through that particular operations we will get some quantitative data, suppose sales. Okay, sales data, production, so how much products you manufactured or produced in a particular period. Okay, so what is the price of the products for past 5 years. Okay, so this type of data, or how much you invested on that particular business and how much you got the return on investment. Okay, so this type of quantitative data, numerical data, we have to analyze that particular numerical data so that we can take a effective decision which will lead a successful business for owners. Okay, so that is the definition. Actually, you just see the definition. Quantitative techniques can be understood as a collection of mathematical and statistical tools that are used to provide powerful means of analysis using quantitative data for effective decision making in business. And another definition for quantitative techniques is These techniques involved in systematic and scientific methods for solving complex problems for taking effective business decision. So whatever you are doing, so whatever decision you just take, why we are doing these particular things means to analyze the quantitative data so that we can take the effective decisions. So for that, first we have to know what is the data, because through the data only, that means whatever techniques we are applying on that particular data only, we are applying these particular tools. Okay, so what is data? Actually data is a raw form of information. That means for any situation, if you want some data, that means the data is in a raw form. When you apply that particular data to that particular situation, then it will become information for that particular situation. But when you are keeping a records, it is a data, it is not information for that particular situation. Okay, so for a particular situation, if you use that particular data, then it becomes an information for that particular situation. So that's why data is a raw form of information used for decision making in the business. Okay, so two main types of data. One is quantitative data and second one is qualitative data. So what is quantitative data? Quantitative data is means you are you can measure that particular data in a numerical form. Okay, so height of the person, weight of the person, okay, marks of a students. Okay, these are quantitative data, discrete data and continuous. So again, quantitative data is discrete data or continuous data. Later we will discuss these particular topics, discrete data and continuous data. First, quantitative data can be expressed in a number. Okay, and qualitative data, actually qualitative data, what is qualitative data means you can't express this type of data into numerical terms. That means intelligence of a person. Okay, maybe you can assess the intelligence of the particular person through the IQ rank or the marks of that particular person, but you can't directly assess the intelligence of that particular person or skills or knowledge. Okay, so these are the qualitative data because we can't measure that particular data in a numerical terms. Okay, so again, suppose if you want to collect a data, so which type of data we can collect? Okay, so again, for collecting data we have primary data and secondary data. So what is primary data? Primary data means first hand data. That means the person itself will collect that particular data. Okay, that means he will collect that particular data under the control and supervision of a particular investigator. Okay, suppose you want to investigate that particular situation, then you will collect the data. Okay, so that type of data is called primary data. And secondary data means the investigator doesn't collect that particular data at that particular situation. Beforehand that particular data is existed, they will use that particular data for that particular purpose. That is called secondary data. That means newspaper or magazines, okay, or statistical reports, okay, government agency records or reports. Okay, these type of data, that means for a particular situation you are not surveying or you are not collecting that particular data. That data was already collected and reported or recorded. You are just using that particular data for this particular situation. That is secondary data. Okay, so these are primary data and secondary data. So how you can collect this primary data? So for collecting primary data, we have some methods. So what are the particular methods? Observation method, questionnaire method, personal interviews, mail questionnaire, and telephone interviews. So observation method. So observation method means you have to observe a particular person or you have to observe the situation where you want to collect the data. Through the observation, you will collect the data. That type of method is called observation method. Here you are not interacting with any person. You are just observing the situation or observing the behavior of that particular person. You are not contacting that particular person directly. So that type of method is called observational method, but it is somewhat biased because by observing what we are perceiving, sometimes we'll get bias because we don't know exactly why that particular behavior was exhibited by that particular person. That means deep information, we can't get the deep information. We can see that particular situation and we analyze that particular situation, that's it. Okay. And next one, questionnaire method. Questionnaire method means beforehand you will prepare a particular questionnaire and you will distribute that particular questionnaire to the respondents. Okay, so whomever you want to collect the data, you will give that particular questionnaire to that particular person. That particular persons are called respondents because they have to respond to your questionnaire. That's why they are called respondents. Okay, so you are distributing the questionnaire to the respondents and they will answer the questionnaire and return back to this particular investigator. So through that particular questionnaire also you can collect the data. That is also first hand data. Okay. And next one, personal interviews. Personal interviews means face to face, directly you are asking the question, and that particular respondent will respond to your answer, that means your questions. Okay, so that is called personal interviews, and personal interviews are conducted face to face. Okay, maybe you have a questionnaire beforehand, but directly you are approaching that particular person and you are asking the question to that particular person. Okay. And mail questionnaires means you are preparing the questionnaire but directly you are not distributing that particular person, you are sending a mail. Through the mail you are sending the questionnaire, and after filling that particular questionnaire, the respondent will send back that particular questionnaire through the mail. Okay, so that type of method is called mail questionnaire. And last one is telephone interviews. Telephone interviews means the interview was conducted through the phone, through the telephones. Okay, that means directly face to face, they never contact with each other. Through the phones or through the mobiles they will ask the questions and respondent will respond to that particular questions on that particular phone. Okay, so that type of method is called telephone interviews. So these are some of the methods for collecting a primary data. And as we already discussed, questionnaire method. Okay, so in questionnaire method we have to prepare the questionnaire, right? So when you are preparing a questionnaire or designing a questionnaire, uh, which type of factors you have to consider? Okay, so designing of a questionnaire, first you have to prepare a covering letter. That means after preparing a questionnaire, when you are sending that particular questionnaire to the respondent, you have to prepare a covering letter. That particular covering letter must contain what is the purpose of that particular questionnaire and why that particular person has to respond to that particular questionnaire, and what are the rewards you are giving to that particular respondent for responding to that particular questionnaire. Because when without any rewards no one will respond to that particular questionnaire. Okay, if they are not responding automatically, you can't get a plenty of information. For taking any decision you need data. For collecting that particular data you have to give some reward to that particular person for responding to your questionnaire. So for that reason, in covering letter, first you are mentioning what is the purpose of that particular questionnaire, and what are the rewards that particular respondent will get after filling that particular questionnaire. So this type of information you have to provide in the covering letter. Okay, with that particular covering letter only you have to send the questionnaire to that particular respondent. And next one, number of questions should be kept to the minimum. That means you can't ask the respondent 100 questions or 150 questions, because for responding that much of questions it will take a long time and they will be frustrated. They don't give exact answers. Even though they give answers, maybe the accuracy of that particular answers maybe in a suspicious way. So that's why whatever questions you are asking, that must be minimum number. The ideal number of questions must be in a questionnaire is 40. That means 25 to 40 questions. But after 25, that means in any questionnaire, suppose if questions are more than 25, then you have to divide that particular questionnaire into two divisions or three divisions according to the topic. Okay, then that particular respondent will not be frustrated by giving answers to that much of questions. So ideal questions is 25 to 40. Okay, and next one, questions should be simple, short, and unambiguous. Okay, that means whatever questions you are asking, that must be very simple. You can't ask lengthy questions, and it must be short. Okay, language wise also, it has to be very simple language. That means the words we are framing in that particular questionnaire, that words must be a that means common words. Okay, generally which type of language we are using, so that type of words you have to use, simple and understanding and very short. And unambiguous means it can't confuse the person how to take that particular question. Because suppose if you ask the person, uh, what is the that means are you literate? Because literacy, the meaning of literacy sometimes tell you whether you are graduate or not. That means graduates also called as literates, right? So but here you are asking, are you literate? That means maybe you are asking, are you graduate, or you are asking whether you are that means you are a educated person or not. Okay, so here this particular question has a unambiguous. That means you are not clearly mentioning whether that particular person is a educated, or whether that particular person's level of education, what you are asking. Okay, so that type of questions are called unambiguous. That means they are confusing the persons. Okay, so that type of questions we have to avoid in our questionnaires. And next one, questions of sensitive or personal nature should be avoided. So we can't ask a confidential information, personal life information, because sometimes maybe you can ask the income levels of that particular person. Still it is a confidential information. You can assure that particular person that this type of confidential information will be kept secretly. Okay, you have to assure that particular person. Okay, after then only you can ask the confidential information, but you can't go to the personal life of that particular person. Okay, that type of questions should be avoided. And next one, answers to questions should not require calculations. That means for some type of questions maybe you need some calculations. Okay, so that type of questions must be avoided. If necessary you can include one or two questions, but we can't include much that type of questions, because calculation will frustrate the persons, or they sometimes they will be hesitated to give answers. Okay, so for avoiding that type of situations, we have to avoid that type of questions where the calculations are required. And next one, logical arrangement. That means, okay, you have a questions, you have 25 questions. The sequence of the sequence or order of arranging that particular questions is also very important. So how you are arranging that particular questions? First, the questionnaire must be introduction questions. That means the name of that particular person, what is the designation of that particular person. Okay, or education background of that particular person. Okay, this type of introduction questions. And then in the middle of the questionnaire you can ask the critical or important questions of your topic. And lastly you can ask is simple questions. That type of arrangement we have to frame for questionnaire. Okay, that logical arrangement must be that means order of that particular questionnaire must be logical. And next one, cross check or footnotes. Cross check means, because I already told you, sometimes you have to cross check the accuracy of the particular answers. So that you have to cross check whether that particular person has given a accurate answer or not. Okay, so sometimes you have to give some footnote means, suppose if you use any technical words, and that particular word is not a common, right? So you have to give elaborate meaning of that particular technical word. So that must be given in a footnote of the questionnaire, so that the person, if that particular person want to review that particular word, what is the meaning of that particular word, they can review in the footnotes. Okay, so that type of cross checking footnotes must be included in your questionnaire if necessary. Okay, so this type of designing is very important for preparing a effective questionnaire. And how you can edit the primary data? For editing primary data, we have to consider again four factors. One is completeness. So completeness means when you send that particular questionnaire and respondent has responded, whether that particular respondent responded to each and every question or not, they completely answered the questions or not. If they are not completely answered, again you have to ask that particular person to fill that particular gap. Okay, so if that particular person is not filling and that particular question is important, then you have to avoid that particular questionnaire. But before avoiding, you have to request that particular person to answer to that particular questionnaire, because we need much data, we need accurate and much data. That's why we want more questionnaires must be completed. Okay, so completeness is very very important. And next one is consistency. Consistency means the answers given by the respondent must be consistent. Okay, the same answer, for a same answer, he can't respond in a dual way. Okay, suppose if you ask in the above question, are you married, and in the below question you asked how many children you have. In the first question he has given no, and for the second question he has given 4 children. That is not consistent answer, right? So that's why consistency is also very very important. And next one, accuracy. Accuracy means how much correctly they are responding to that particular questionnaire. Okay, cross checking. In designing questionnaire, we discussed about cross checking. Here also, randomly, we are cross checking some of the questions. Okay, whether that particular questions were consistently answered, or whether that particular questions answered are accurate or not, or that means they are matching to that particular questions or not. Okay, so we have to check the accuracy of the questions also. And last one, homogeneity. So homogeneity means the questions which are posed in that particular questionnaire must be that means understand by the each and every respondent in a equal level. That means suppose if you ask the income, what is the income of you, that means how much income you are earning. So you are not mentioning that particular income must be expressed monthly or annually, and you are not that means exactly expressed that particular income must be expressed in rupees or dollars, right? So that's why this particular homogeneity is also important. That means you have to ask a elaborate question, exact question, so that the respondent, each and every respondent will respond to that particular question in a unique way. That means same way. Okay, so these are the main factors for editing the primary data. And what are the sources for secondary data? As we discussed, primary data, for collecting primary data we have different methods, but secondary data, it is already collected, so we don't have any techniques for collecting secondary data. We have some sources for collecting the secondary data. Okay, so what are the particular sources? So published sources. So published sources means, as I already told you, newspapers, okay, journals, okay, business magazines. So these are the published sources. And unpublished sources means confidential data. Maybe that particular confidential data is related to your business or government or private agencies. Okay, so that type of information is not published publicly. So you have to request that particular agency, or you have to request that particular persons to give that particular data for your survey purpose or for your business purpose. Okay, so that type of data is called unpublished sources for collecting the secondary data. And next topic is sensex and samples. So what is sensex and what is sample? Actually, sensex is known as each and every item of the population is included for your survey, then it is called sensex. That means suppose you want to collect the information. Okay, so suppose you have taken a Kakinada as a that means as one of the place for collecting the data. So in Kakinada, how many population are there, each and every one you are including, then it is called sensex. That means each and every item of that particular population is included. Okay, that is called census. Suppose if you want a sample, what is sample means, you are not considering the whole population of the Kakinada, you are considering some parts of the population in that particular region. That is called sample. That means the probability of some of the people are included in your survey. Each and every one is not included in your survey. Some part of the population is included in that particular survey. That is called sample. Okay, and you are inferring the information collected from that particular sample, and you are generalizing that particular results. And next one, classification of data. Okay, so what is classification of data? As we discussed, okay, collecting data, and we discussed editing data. Now we have to know what is the classification of data. So once you collected the data, then you have to classify that particular data. How we can classify the data means, with the similarities and dissimilarities of that particular data, we are arranging the data. Okay, that type of arrangement is called classification of data. So classification is the process of arranging the data according to the points of similarities or dissimilarities. Suppose, as I already told you, suppose if you are taking a particular region's population, okay, you can consider male people and female people. That means here similarity is male gender. Okay, so in gender, male people is the similarities and female people is the similarities. So based on that particular similarities, you are arranging the data, collected data. So that type of process is called classification of data. Okay, so what are the types of classifications? So if you want to classify that particular data, which types are available? One is geographical data. Geographical data means, as I already told you, for a particular region. Okay, for a particular region, what is the data collected, what is the results of that particular data collection. Okay, so you are arranging that particular data according to the regions, then it is called the geographical classification of data. For example, okay, suppose if you want wheat production. Okay, so the statistics of a wheat production in whole India. So you are considering Andhra Pradesh, you are considering Telangana, you are considering Kerala, you are considering Punjab, you are considering West Bengal. So region wise, what is the production of wheat in for a particular period, you are classifying that particular data. Okay, so that type of data is called geographical data. And next one, chronological data. So chronological data means, for a particular time period, with respect to time, we are classifying the data. So for example, year 1992 to 93, 1993 to 94. Okay, so that type of classification, according to the time period, we are classifying that particular data. That is called chronological order. And next one, quality. So quality, it means, as I already told you, attributes. We are considering the attributes. That means education, or the knowledge of that particular person. Okay, so, or beauty of the particular person. Okay, so these type of things, these type of attributes. Okay, we are collecting the data about that particular attributes, then it is called qualitative data. Okay, here, as I already told you, for education we can't measure that particular person. That means that particular factor numerically, but we can measure that particular thing through education. Means, maybe he is a 10th passed, or inter, or graduate, or postgraduate, or doctorate. Okay, so through this particular information, you can measure the education level of that particular person. That's why it is called attributes. These are the attributes. We can't measure the attributes in a numerical form. Okay, or numbers. And quantitative data. So quantitative data means, this particular data can be measured in numerical form. That's why these are called variables. So variables can be measured in a number. That's why qualitative. So in qualitative, if you are classifying the data, then you are classifying the variables. Okay, for quality, if you are classifying the data, you are considering the attributes. So that is the difference between qualitative and quantitative. And again, in quantitative, we have two classifications. One is discrete and second one is continuous. So in discrete, you are considering our discrete data refers to the quantitative data that is limited to integer number value of the variables. So you are considering the integers. Suppose number of employees and number of companies. Suppose number of employees are 110 for 25 companies, 120 number of employees in 35 companies, so 130 employees in 70 companies. So here you are considering the integer numbers. Okay, so that type of data is called discrete data. And continuous data means you are taking the time intervals. Okay, so 20 to 25 age, 15 workers are there. 25 to 30 years, 10 workers. That means you are considering the interval, you are not considering the direct integer, you are considering the intervals. That type of data is called continuous data. And next one is frequency distribution. Frequency distribution means here in the above example, number of workers is the frequency. That means 15, 10, 20. Okay, so for a particular company, the age group, the workers who are in the age group 20 to 25, they are 15. So here frequency distribution or frequency is 15. Suppose the workers, number of workers who are between 25 to 30, 10. So here the frequency is 10 employees, 10 workers. So the frequency distribution means number of observation, who falls under that particular category. That is called frequency distribution. And next one, construction of a continuous frequency distribution. As we discussed, okay, last example is the continuous frequency distribution, 20 to 25, 25 to 30, 30 to 35. That means here we are not taking the number, we are taking the intervals. So for constructing this type of data, what is the main factors or main definitions we have to consider? So class limit. So what is class limit? Class limit denotes the lower and higher value that can be included in the class. So lower and higher level values. That means suppose 25 to 30. So here 25 is the lower value and 30 is the higher value. So these are the class limits of that particular continuous distribution. And next one, class interval. So class interval means the interval represents the width or span of that particular class. That means suppose here 10 to 20, the difference between 10 to 20 is 10, right? Suppose 25 to 30, so the class difference is 5. So the difference between lower level value and higher level value is the class interval. And next one, class frequency. The number of observations falling within the particular class is called its class frequency. In last example, okay, so 20 to 25 we have 15 workers. So 15 is the frequency, that is the class frequency. Okay, so class frequency means number of observations falling within the particular class. Okay, and next, class midpoint. So class midpoint means suppose take 10 to 20, the midpoint means 10 plus 20 by 2. That means 30 by 2 means 15. So the point which lies between that particular two intervals is called midpoint. Suppose 20 to 30, 25 is the midpoint. Okay, so like that, the middle value of that particular class levels is the midpoint. Okay, and next, types of class intervals. Okay, so the next topic is type of class intervals. Means there are two types of class intervals. One is inclusive exclusive method and open end. So inclusive exclusive method. Okay, so in exclusive method, we are considering the continuous. Okay, that means the class intervals are so arranged that the upper limit of one class is the lower limit of the next class. Suppose take 20 to 25. Okay, and 25 to 30, 30 to 35. That means last class higher upper level is the next class lower level. So 20 to 25 is the one class. Here 25 is the upper limit, but next class interval is 25 to 30. That means 25 is the lower limit. That means one class upper limit becomes next class lower limit. Okay, that type of method is called exclusive method. And inclusive method means here this particular upper limit of one class included itself. Okay, so that means for that particular interval level, that value will be ended in that particular interval level only. Next interval level will start with the next number. Okay, so that type of method is called inclusive method. That means 10 to 20, 20 to 24.999. Okay, next 35 to 39.999, 25 to 29.999. That means you are considering the number, upper limit number for that class itself only. You are not proceeding that particular number to the next level. Okay, so that is inclusive method. So exclusive method and inclusive method. Then next method is open end. So in open end, mainly the lower limit of that particular distribution and higher class of that particular distribution is not exactly specifically, that means what we say, specifically mentioned. Okay, so here just see the example less than 10,000. They are not mentioning exact levels. Okay, exact class levels. That means 1000 to 1500 or 1500 to 2000, like that. They are not exactly mentioning. They are saying less than 1000. Okay, that is open end, because here they are not specifically mentioning the values. Less than 1000 means it is not a exact time pair the time sorry class level. Okay, and last one 25,000 and above. 25,000 above means they are specifically not mentioning that particular class. Okay, so the upper or lower limit and upper limit of the particular distribution is not specifically mentioned. That type of method is called open end method. Okay, so this type of continuous distribution is also existed in data collection, in data representation. And next one, charting of data. Once you arranged or categorized or classified that particular data, then you have to represent that particular data. So, or you have to present that particular data. How you will present that particular data? Through the charts only you will present that particular data. So bar diagrams, histograms, so frequency polygon, or cumulative frequency curve, or ogive. Okay, so this type of different graphs are existed. Okay, so for first graph, bar diagram, this is the common presentation for the data. Why? Because it is very easy to administer. The data can be administered very easily, and it can be understand very easily. So that's why commonly they are using bar diagrams. Okay, and next one is histogram. Histogram means here for frequency distribution. If you want to focus on frequency distribution, you can use this type of data, histograms. Okay, and frequency polygram also, here also you are mainly focusing on frequency distribution, but you are considering the midpoints of the class intervals, as we discussed. Suppose 10 to 20, 15 is the midpoint, 20 to 20, 30, 25 is the midpoint. That means here you are considering the frequency distribution as well as midpoints of that particular class interval also. So for representing these two factors, you are using frequency polygon. Okay, so these are different types of charts which are available for data presentation. Okay, and now measures of central tendency. So here mainly in measures of central tendency, we are mainly going through different topics. Which are the particular topics? Means arithmetic mean, weighted arithmetic mean, median, quartile, mode, geographic mean, and harmonic mean. So we discussed about arithmetic mean. So what is arithmetic mean? Arithmetic mean is nothing but It is the equal number of, that means sum of numerical values of each and every observation divided by total number of observations. That means, suppose if you have a series of 10 numbers, so total number of observations is 10. But here maybe first observation is 15, second observation is 20, third observation is 30. Like that we have different values for each and every observation. So you have to sum all and every observation, then you have to divide that particular sum by total number of observations. So that is the definition of arithmetic mean. And for example, you just see the problem. So here in problem we have 2500, 2700, 2400, 2300, 2550, and 2650, 2750, and 2450, 2600, and 2400. So here we have number of observation means 10 number of observations, right? So first you have to sum up all the values and then divided by 10. So what is the value? 2530. So that is the arithmetic mean for a series of data. Okay, suppose if the data is presented in series level, then this is the formula. Suppose that particular data is presented in continuous form, that means class intervals and frequency distribution, then you have to use x bar or average. Average is represented in x bar. X bar is equal to sigma fx by n. So sigma fx by n. So that is the formula for the data which is represented in continuous series for calculating the arithmetic mean. Okay, so for example, you just see this particular problem. Okay, here they have mentioned monthly sales and number of forms. So here monthly sales 300 to 355, 350 to 400 14, 400 to 450 23, 450 to 550, 500 to 550 to 52, 550 to 600. Number of forms is 25. 600 to 650, number of forms is 22, and 650 to 700 7, and 700 to 750 frequency or number of forms is 2. Okay, so this is the data given and you have to calculate the arithmetic mean for this particular data. So first you have to calculate, that means you have to take the data, monthly sales, midpoint, and frequency. So monthly sales is already given, the class intervals, and the number of forms, frequency, it is also given. And you have to collect the midpoint. Midpoint is represented with capital X. Okay, so capital X. So for 300 to 350, the midpoint is 325. 350 to 400, 375. 400 to 450, 425. So like that, for 700 to 750, the midpoint is 725. So you have the value of X, capital X, and now you have the value of F. F is already given in the problem, right? Now you have to calculate Fx. So Fx means for first series 235 into 5. So 325 into 5. So 325 into 5 means Fx is 1625. And for next one 375 into 14, 5250. Like that you have to calculate the Fx. Once you calculate the Fx, you have to sum up all the values. That is called sigma Fx. Okay, and if you sum up all the frequencies, F, that is n. Okay, number of observations is comes from the frequency, sum up the frequencies. Okay, then that is the value of n. So here value of n is 200 and sigma Fx is 10,000 to 1 lakh 2,000. Okay, so 1 lakh 2,000 by 200, that is 510. Okay, so this is the second model for calculating arithmetic mean, and this is another model for calculating the arithmetic mean. The formula is x bar is equal to a plus sigma fd by n into I. So here you are considering the class intervals also. Okay, so for this particular, through this particular formula, if you want to calculate the arithmetic mean, again you have to use the table. So in this particular table, as we already discussed, so here the monthly sales is given in the continuous series and frequency is also given. So you have to calculate the midpoint of the class intervals. So we have three values, Now you have to calculate capital X minus A by I. Okay, so here X minus A, how you will get the A? A value is the middle term of the midpoint. That means here the number of observations are 10, right? So sixth observation, you just consider fifth observation. Fifth observation is midpoint. In midpoint, fifth observation is 525, right? So it is the middle observation. So that is the assumed value. You can consider that value as a assumed value. Okay, so x minus 525. X minus a means assumed arbitrary point is 525. X minus 525 by 50. 50 means, how you get 50 means I. So so I means interval, gap of the interval, class interval. So here 300 to 350, the class interval is 50. 350 to 400, again the class interval is 50. That's why I is 50. So x minus a by 50. Here x value is the middle point. Okay, the midpoint value is called x. Okay, so here for getting minus 4, you have to calculate x minus 525 by 50 means, here x means 325. So 325 minus 525 by 50 minus 4. Like that, 375 minus 525 by 50 minus 3. 425 minus 525 by 50 minus 2. So like that, you have to calculate the d. Okay, once you calculate the d, then you have to calculate f into d, fd. So here f means number of forms. Okay, so f is already given in the problem, and d we already calculated. Then you have to multiply these two values. So f into d, 5 into minus 4 minus 20, 14 into minus 3 minus 42. So like that, you have to calculate fd. So here n means d, sum up all the values, sum up all the values of f, that is n. Okay, here he has given n value at the lower level of d, but it is not sum up all the d's, it is sum up of all the f's is called n. Okay, 5 plus 14 plus 23 plus 50 plus 52 plus 25 plus 22 plus 7 plus 2, that is n is equal to 200. And fd, so sigma fd is minus 60. So now apply these values in the formula. X bar is equal to a plus sigma fd by n into I. So a value is 525. We already calculated arbitrary point 525. That is from midpoint, right? So 525 plus sigma fd is minus 60. Okay, so minus 60 by n, 200 into I, 50. So you will get the arithmetic mean 510. So this is another method for calculating the arithmetic mean. Suppose if they ask you calculate the arithmetic mean through arbitrary point, then you have to use this particular formula. Suppose if they ask you calculate the arithmetic mean, then you can use this particular formula sigma fx by n. Okay, because these both data is same. Okay, so if you just compare, the problem is same, but we are using that particular same data by for different techniques. Okay, we are applying different techniques. One is sigma fx by n, and another one is a plus sigma fd by n into I, but the data is same. Suppose if they ask you calculate the arithmetic mean through arbitrary point, then you have to use this method. And next one is weighted arithmetic mean. So weighted arithmetic mean means when you have a grading system. Okay, that means you have weighted averages, different weighted averages. Okay, then you have to use this particular method. That means you are familiarized with the use of weighted averages to combine several grades that are not equally important. Okay, for example, so for a particular person's final exam results, if you want to know the final exam result of a particular person through the grading system, okay, so here in this particular grading system, they are using three grades. One is final marks, final exam marks. Second one is assignment marks, okay, or mid marks, midterm assignment marks. So first mid assignment marks, second mid exam assignment marks. Okay, so for final exams they have given a weightage of 50%, and for first midterm assignment they have given 25%, and for second midterm assignment they have given 25%. So these are the weightages. Okay, so grades are the final marks which are obtained by that particular persons. So here suppose x bar w is equal to sigma wx by sigma w, right? So here w means weights, okay, weightages, whatever weightages we are considering. Okay, x means how much marks they scored in that particular exams, that is x. So sigma wx is equal to w1 into x1 plus w2 into x2 plus w3 into x3. Here w1 x1 means final exam grades and marks. W2 x2 means first mid examination, first mid assignment marks, and w3x3 means second mid assignment marks. Okay, so here we have considered final exams. For final exams we have given 50% of weightage, so 50 into x1 plus w2 x2 means here w2 for first mid assignment we have given 25%, so weightage is 25, that means 25 into x2 plus W3 X3 means for second internal exams also we have given weightage of 25%. So 25 into X3 by W1, W2, W3. That means weightages 50 plus 25 plus 23. Now for this particular exam they have given the final marks also. So suppose you got 80 marks in a final examination, 95 marks in first midterm assignments, and 85 marks in second midterm assignment, then you have to use these particular marks as x1, x2, x3 and calculate x bar w. Okay, so you will get 85. So this is called a weighted arithmetic mean. So if you have a weightage system and you have to calculate the arithmetic mean, then you have to use this particular method. And next one, median. So what is median? Median is nothing but a middle point of the particular series or particular distribution. This will divide the distribution into two equal parts. That is called median. So median is the value which divides the distribution into two equal parts. So when this particular distribution will be two equal parts, when you consider the middle point or center point as a middle point, then you can divide this particular distribution into two equal parts. That's why median is nothing but a middle point of that particular distribution. Okay, so how you can calculate the median? So for observations which are odd number means suppose observations are three observations or five observations is given or seven observations are given, so number of observations are in an odd number, then you have to use n plus 1 by 2. Okay, suppose here you just see, for example, 1100, 1200, 1350, 1500, 1550, 1600, and 1800. So how many number of observations are there? 1, 2, 3, 4, 5, 6, 7. So 7 observations are there. 7 means odd series. So observations are in odd number. So n is 7, n plus 1 by 2. That means 7 plus 1 by 2, 8, 8 by 2, 4. So what is the fourth observation? 1100 is the first observation, 1200 is second, 1350 is the third, 1500 is the fourth observation. So 1500 is the median of this particular series. So middle point of this particular series. Suppose if the observations are even, that means for odd n plus 1 by 2. That is the formula for finding the median. But for even number of series, that means maybe that particular series has a 10 number of observations. or it contains 12 12 number of observations. So even number of observations, then how you will calculate that particular median? So middle value of the observation by 2 is the median. That means suppose you just take from the above example, you are adding another number 1850, because from the above observation we have number of observations are 7, right? In the above problem we have number of observations as 7. Now you are adding another value, that means now the number of observations are 8, right? So the event series, so here in event series how you will calculate the median value means sum up the fourth position of the value and fifth position of the value. That means 1500 plus 1550 by 2. So middle number of values by 2. That is the median for event series. So 1500 plus 1550 by 2 means 1525. So that is the median for event series. Suppose if that particular data is in group data, because here this particular data is observation series, it is a series of data. Suppose if that particular data is represented in a grouped way, grouped data, then for calculating median, formula is L plus n by 2 minus PCF. PCF means preceded cumulative frequency, preceded cumulative frequency by F into I. So, for example, this is the problem for calculating the median for grouped data. So, grouped data is the example of above problem. So, here the data is not in a series, right? So, it is grouped. That means it is grouped into below 15, 25 to 30, 30 to 35. That means they grouped this particular data. So, that's why it is called grouped data. Okay, so if you have 1,000 of workers and they are grouped according to their ages, okay, so how you will calculate the median age for this particular group data? So here first you have to take the age, okay, and next you have to take the f means number of workers, frequency. Okay, now you have to calculate the cumulative frequency. So how you will calculate the cumulative frequency? Through the frequency only you will calculate the cumulative frequency. So first, in frequency table, the first observation is 120. So in cumulative frequency, the first observation also 120. For frequency, the second value is 125. So you just add first two values, 120 plus 125. So 245. That is the second value in cumulative frequency. Now, for getting third value for cumulative frequency, you have to sum up the three values in the frequency table. That means 120 plus 125 plus 180. So that is the value of cumulative frequency in the third position, 425. Again, if you want fourth value of in the cumulative frequency, here in frequency table you have to sum up the four values, 120 plus 125 plus 180 plus 160, 585, right? So like that till last column. Okay, so you will calculate the all values. Okay, so now you have frequency and cumulative frequency. Okay, now median is equal to n by tooth observation. Okay, so n by tooth observation means 1000 by 2, 500. So 500, this particular 500 observation lies in which interval? That means in which interval this particular 500 observation lies means in cumulative frequency. You just see first cumulative frequency is 120, second cumulative frequency 245. That means from 120 observation to 245 observation, the middle of the observations are lies in that particular interval. And suppose third observation is 425, that means 245, that means 246, 246th observation onwards, 425th observation, till that observation the observations are lies in that particular interval. Okay, so that is the meaning of cumulative frequency. Now we want 500th observation. So 500th observation lies between 425 to 585. So 585 is in the interval of 35 to 40, right? So 585 cumulative frequency lies in the interval of 35 to 40. So that's why you have to consider that class interval 35 to 40. Now, median formula is L plus N by 2 minus PCF by F into I. So here L means lower level of that particular class interval, 35 to 40. So 35 to 40, lower level is 35. So L is 35 plus N by 2, 1000 by 2, 500. 1000 means number of observations. So 1000 by 2, 500 minus preceded cumulative frequency. So preceded cumulative frequency means 500th observation is in the class interval of 35 to 40. So 35 to 40, the cumulative frequency is 585, right? So the preceded cumulative frequency is 425. So the 425 is the value for PCF by F. So frequency for 35 to 40 class interval, okay, frequency is 160 in frequency table. Okay, in frequency table, okay, so F is 160. So 160 you are considering 160 into 5 means, because the class gap is 25 to 30 or 30 to 35, 35 to 40, that means the class interval is 5. So I is equal to 5. Okay, if you calculate that particular formula or values, then you will get 37.34 years. So that is the median age of that particular data. Next, quantiles. So here in quantiles, you are classifying the data into quarters. Okay, four equal parts. Okay, so the distribution or the data is divided into four parts. For dividing that particular four parts, you need 3 points. Okay, suppose if you are dividing a particular that means particular line into four parts, then you need 3 points in the middle, right? Not the end of the points. Okay, suppose if you draw a straight line, you want to divide that particular straight line into four parts, then you have to put 3 points. Okay, with the 3 points only you can cross the that means you can draw the straight lines across that particular 3 points, then you can divide that particular straight line into four parts, right? So that's why in quantile, the distribution, the data is divided into four parts. For dividing that particular four parts, you need 3 points. 3 points, that 3 points are Q1, Q2 and Q3. So Q1 value means it will divide the whole distribution into 25 observations small and 75 observations large. Okay, that means first quartile. Okay, suppose if you have a 20 number, okay, 20 number of observations, so first quartile means first number of 5 observations. Okay, so that 5 observations means 25% of the observations, right? 25% of the observations below that particular Q1, and after that particular Q1 you have 75% of observations. So that is nothing but Q1. And Q2 means middle of that particular distribution. That particular Q2 point lies middle of that particular observation distribution. Okay, that's why suppose 10 in 20 observations, you are dividing the 20 into four quartiles. Four equal part means Q2 comes under 50%. So 50% of that Q2 value, okay, below the 50%, you have smaller observations, and above the 50%, you have larger observations. Again, Q3 lies in 3 by 4th point. So 3 by 4th point means here Q3. Below that particular Q3, you have 75% of observations, and above that particular Q3, you have 25% of observations. That's why it is 3 by 4th point. Okay. So like that, you have to define Q1, Q2, and Q3 points. And Q1, Q2, Q3 points divide the whole distribution into 4 equal quartiles. Okay. So what is the formula for calculating the quartile? Okay, QJ. J means Q1 means 1, 2, 3 because we have Q1, Q2, Q3. Suppose if you want to calculate Q1 in the place of J, you can replace 1. Suppose if you want to calculate Q2, you can replace 2 as a number in J place. Okay, so Qj is equal to L plus J into N by 4 minus PCF. That means preceding cumulative frequency by F into I. Okay, and quartile is over. Then what is the next topic means decile. Deciles. So deciles means you are that means you are dividing that particular distribution into 10 equal parts. 10 in quartile, we are dividing the distribution into 4 equal parts. In decile, we are dividing that particular distribution into 10 equal parts. So for dividing the distribution into 10 equal parts, how many number of points you require? 9 points. That's why in decile you have D1 to D9. Okay, so D1 to D9 because it is a decile, that's why we are using D. In quartile we have Q, that's why we use it Q as a symbol, Q1, Q2, Q3. Decile means D, D1, D2, D3 like the D9. Okay, so for calculating decile, okay, you have to use the formula dk. Dk is equal to L plus K into N by 10 because it is a decile. So you have to divide that particular distribution into 10 parts. That's why N by 10. N by 10. So K into N by 10 minus PCF by F into I. So here in K, place of K, you can use 1 to 9. Okay, suppose if you want to calculate the D1 value, so D1 is equal to L plus N by 10 minus PCF by F into I. Suppose if you want to calculate D3, so L plus 3 into N by 10 minus PCF by F into I. Okay, so in the place of K, you are using that particular number. And last one is percentile. So percent means 100. So here you are distributing, that means distributing that particular data into 100 equal parts. Okay, so 100 equal parts means for dividing that particular distribution into 100 equal parts, you need 99 points. So that's why we use P. Percentile means P1 to P99. Okay, for calculating P1 or P99 or P40, okay, again we have a formula L plus L into N by 100 because it is a percentile, that's why N by 100 minus PCF by F into I. So this is the formula for percentile. So you just see the how to calculate quartile, decile and percentile. So this is the formula, sorry, this is the problem. Okay, in problem they have given profit and number of companies. So profit is given in continuous series. So in lakhs, 20 lakhs to 30 lakhs, number of companies earned this 20 to 30 lakhs, between the 20 to 30 lakhs, 4 companies, and 30 to 40 lakhs profit earned by 8 companies, 40 to 50 lakhs earned by 18 companies, like that they have given 90 to 100 lakhs, the number of companies is 7. So calculate Q1, Q2, D6 and P90 from the given data. Okay, so for that first you have to calculate the CF, that means cumulative frequency. So how we calculate the cumulative frequency means through the frequency. Through the frequency only we will calculate the cumulative frequency. So frequency is given as 4, 8, 18, 30, 15, 10, 8 and 7. So the cumulative frequency 4 means 4. Suppose you want second position of cumulative frequency, again you have to add two numbers in the frequency table, 4 plus 8, 12. Okay, and you want third position, 4 plus 8 plus 18, 30. Okay, next 4 plus 8 plus 18 plus 30, 60. Okay, and next 4 plus 8 plus 18 plus 30 plus 15, 75. Okay, so like that you have to calculate the cumulative frequency. Once you calculate the cumulative frequency, then you have to calculate Q1, Q2, D6 and P90. So for calculating Q1, first Q1 means n by fourth observation, right? So that's why size of n by fourth observation. So here number of n means number of companies. So f, sigma f is the n. So 4 plus 8 plus 18 plus 30 plus 15 plus 10 plus 8 plus 7. So that is the number of observations. So 100 by 4 is equal to 25th observation. So 25th observation is in the cumulative frequency, where that particular 25th observation lies. In the cumulative frequency means at the 30, 12 to 30. So 12 to 30, in between 12 to 30 in the cumulative frequency table, this 25th observation lies. So that's why you have to consider 30, 30. So across the 30 cumulative frequency, the class interval is 40 to 50. So 40 to 50 class interval has a frequency of 18 and cumulative frequency of 30 in the table, right? So here Q1 L means lower level of that particular interval. So 40 to 50. So in 40 to 50, 40 is the lower level. So L is equal to 40. N by 4. N by 4 means already we calculated 25 minus preceded cumulative frequency. Suppose here we have considered 30. So preceded cumulative frequency means 12. Okay, 30 above the value which is lies above the 30 value in cumulative table is 25, 12. So that's why PCF is 12 by F. F means across, that means the value across the 30 in frequency table. Okay, in frequency table, 18 is the value across the 30 in the cumulative frequency, right? So that's why 18, F is 18 into 10. Okay, because 10 I means the difference, class interval. So class interval 40 to 50, the class interval is 10. 40, the difference between 40 to 50 is 10. So I is equal to 10. So if you calculate that thing, then you will get Q1. Okay, and again they asked Q2. So Q2 means 50%. That means n by 2. Okay, so here, so for calculating Q2, you are calculating size of n by 2th observation. That means 100 by 2. So 50th observation. In cumulative frequency, you have to consider where this particular 50th observation lies. So 50th observation lies at 60. Okay, in cumulative frequency, okay, 60. 60 value has a 50th observation. In that particular interval, we have a 50th observation in that particular 60 value. Okay, so that's why here you have to consider 60 cumulative, that means 60 value. Okay, so for 60 value, across the 60 value in frequency table we have 30 at 30, and in class interval we have 50 to 60. So if you consider 50 to 60 class interval, the frequency is 30 and cumulative frequency is 60. So that is required for Q2. So Q2 is equal to L plus N by 2 minus PCF by F into I. Again L. L means 50 to 60. The lower limit is 50. So 50 plus N by 2. 100 by 2 means 50. 50 minus PCF, that means preceded cumulative frequency. So for 60 in cumulative row, the value preceded by the 60 is 30. Okay, so you are considering the 30 PCF by F. So F means 60. Across 60 we have 30. In frequency table we have 30 value. So that's why you are taking 30 into 10 is equal to, you will get 56.67. So that is Q2. Once you get the Q2, then you have to calculate D6. So how you will calculate the D6? D6 means decile. Decile. Decile means 10. 10 equal parts. So D6, that means 6n by 10. So size of 6n by 10. So n means 100. So 6 into 100 by 10. Okay, so 600 by 10, that means 60th observation. So 60th observation lies in the above table means cumulative frequency. In cumulative frequency row, you have to consider 60th value. So 60th value is in the fourth position. In cumulative frequency, the fourth value is 60, right? So the 60th observation is lies in that particular 60th value. Okay, so that is the class interval 50 to 60. The frequency is 30 and the cumulative frequency is 60. Okay, so here again the formula L plus 6n by 10 minus PCF by F into I. So here class interval is 50 to 60. So the lower limit is 50. That's why you are considering L as a 50 plus 6n by 10. So 6n by 10 means 60 minus preceded cumulative frequency. Here we are considering 60 as the cumulative frequency for this particular thing, for this particular problem. So 60 preceded value is 30. So 30 is preceded cumulative frequency by frequency. So frequency, that means in frequency table, again across the 60 you have 30 as the frequency. So you are considering 30 by 30 into 10. So the value is 60. So D6 is equal to 60. Okay, P90. P90 means percentile, 100. Okay, so here they are asking P90. That means 90 n by 100. So 90 into n means 100 by 100. So 100, you will cancel that two values and you will get 90th observation. So this 90th observation, you have where you have to consider the 90th observation in cumulative frequency. Okay, in a cumulative frequency column, you have to see the 90th observation. So the 90th observation lies at 93. Last but one value, 93. That in that particular class interval, 90th observation lies. Okay, so here the cumulative frequency is 93, frequency is 8, and corresponding time class interval is 80 to 90. So 80 to 90, frequency F is 8 and cumulative frequency is 93 and preceded cumulative frequency is 85, because above value of 93 is 83, 85. So the preceded cumulative frequency is 85. Okay, now you apply that particular values in this particular formula. L plus 90 n by 100 minus PCF by F into I. Okay, so L means class interval 80 to 90. So the lower limit is 80. So 80 plus n 90 n by 100 means 90 minus preceded class interval is 85. In cumulative frequency, 85 is the preceded class cumulative frequency. So 85 by frequency F 100, sorry 10 into class interval I, 80 to 90, the class interval is 10. Okay, so the total value is 85. So like that you will calculate, you have to calculate P90 or P95. Suppose if you want to calculate P95, then you have to use the 95 into n by 100. Okay, so that observation you have to calculate. So this is the method how to calculate Q1, Q2, D6 or P90. And next one is mode. So how to calculate the mode? Okay, so what is the mode? Mode means the greatest frequency or most often value in that particular distribution. Okay, for example, 3, 4, 5, 5, 6, 7, 8, 8, 8, 9. Here 8 comes in 3 times, 5 comes in 2 times. So how that means greatest frequency number is that means repeated value. Repeated value is 8 because 8 is in 3 times, right? So that's why mode is 8. Okay, so that means the value, it defines the value which occurs most often or with the greatest frequency. That value is called your mode. Okay, for group data, for calculating mode, L plus D1 by D1 plus D2 into I. So how to calculate D1, D2 and I? Okay, so L means lower limit of the model class. So as we already discussed, suppose if you have a class interval 80 to 90, then the lower limit is 80, right? So like that lower limit of the model class. And D1, so how you will calculate the D1 means difference between the frequency of model class and frequency of the preceded class. So before class frequency and this particular model class frequency, the difference between these particular two class frequencies is D1. And D2 means difference between frequency of model class and frequency of the succeeding class, that means below class. So the model class and below class frequency, so difference between these two frequencies is the D2. And I is size of the model class. So how to calculate a mode? Okay, for this particular problem, okay, 20 to 30, 15, 30 to 40, 23, 40 to 50, 27, 50 to 60, 20, 60 to 70, 35, 70 to 80, 25, and 80 to 95. Okay, so here the sales number of forms. Okay, so if you observe number of forms, that means F 15, 23, 27, 20, 35, 25, and 5. So which is the highest number? 35 is the highest number. So here in this particular table, the model class is 35 because this is the highest number. So you have to consider the highest number or greater frequency. So greater frequency is the 35 number. So this is the model class. So 35, across the 35 we have 60 to 70. Okay, so 60 to 70 is the model class. Okay, now you apply this particular values in the below formula. L is L plus D1 by D1 plus D2 into I. Okay, so here the model class is 60 to 70, L is 60. Okay, 60 plus D1. D1 means, as we discussed, the difference between model class frequency and preceded class frequency. So here 35 above frequency is 20, right? So 50 to 60, 20, 60 to 70, 35. So preceded class. So 35 above value is 20. So here you are considering 35 minus 20. It is the D1 by D1, again 35 minus 20 plus D2. D2 means the difference between model class frequency and below succeeded class frequency. So 35 below value is 25. So 35 minus 25, that is the D2 value. If you calculate this, then you will get the model value of that particular class. So next one is measure of variation. So till now we discussed about measure of central tendency. Now we are discussing about measure of variance. That means variation in that particular data distribution. What is the variation of or scatterness of values in that particular distribution? So you have to calculate the frequency level of that particular scatterness. Okay, so for calculating this particular variation, we have different methods. One is range, second one is average or mean deviation, quartile deviation, And next one, standard deviation. So range is nothing but a difference between highest value and lowest value. So R is equal to H minus L. So if you have, for example, we have a series of numbers 5050, 5025, 4950, and 4835, and 5140. So what is the highest value in this particular series? 5140 minus lowest value 4835. So the difference between highest value in that particular series and lowest value is nothing but a range. Okay, and next one, quartile deviation. So that means quartile, half half of the particular deviation is called quartile deviation, or the quartile deviation is computed by taking the average of the difference between third quartile and first quartile. Okay, so you are taking the difference between these particular two quartiles, third quartile and first quartile, and you are averaging with that particular thing. That means by 2. Okay, so QD, quartile deviation is equal to Q3 minus Q1 by 2. Okay, so how we will calculate Q3 and Q1? So this is the problem. Okay, monthly wages below 850, 850 to 500, sorry, 900. So number of workers 12, 16. Okay, so this is the problem given. Okay, so you have to calculate the quartile deviation for this particular problem. Okay, first you will take the data, monthly wages, so below 850, number of workers, it is a frequency 12. Okay, 850 to 900 16, 900 to 950 39, and these values are given in the problem. Now you have to calculate the cumulative frequency, so you have to add the frequency. Okay, so first value as it is 12 12. Okay, and next value in cumulative frequency, you have to sum up the two values in the first two values in the frequency. So 12 plus 16, 28. For third value in the cumulative frequency, you have to sum up the three values in the frequency. So 12 plus 16 plus 39, 67. So like that, you have to calculate the cumulative frequency. So once you calculate the cumulative frequency, then calculate Q1. First, for calculating Q1, size of n by 4th observation, because Q1 means 1 by 4, right? So that's why you have to calculate size of n by 4th observation. So n means here number of workers, 12 plus 16 plus 39 plus 5, 56 plus 62 plus 75 plus 30 plus 10. So total number of frequency observations. Okay, so that is n. So that is 300. So 300 by 4, that means 75th. So okay, 75th observation. So in cumulative frequency, you have to consider 75th observation comes under which class. Okay, so first cumulative frequency value is 12, second value is 28, third value is 67, fourth value 128. So 75th observation at 123, because third class up to 67th observation it will end. Okay, from 68th observation to 123rd observation, these all observations lies in this particular interval 950 to 1000. 950 to 1000, the frequency is 56 and cumulative frequency is 123. In this particular level, this 75th observation lies. Okay, now you have to calculate Q1. So Q1, L plus N by 4 minus PCF by F into I. So here the class interval is 950 to 1000. So the lower level is 950. L is equal to 950 plus N by 4. N by 4 means 300 by 4, 75 minus preceded class interval 123. So in class cumulative frequency 123, above 123 is 67. So that is the preceded cumulative frequency. So 67 by frequency. Okay, in frequency table, one the value 56 is across the 123 in cumulative frequency, right? So 56 is the frequency into 50 interval 950 to 1000, the difference is 50, so that's why I is 50. Okay, if you apply these particular values on the above formula, then you will get 957.14, that is q1 value. And q3, so q3 means size of 3n by 4. So 3n by 4 means 3 into n means 300 by 4, so 75 into 3, so 225. So 225 observation. So in cumulative frequency, you have to consider this particular 225th observation lies at which class interval. So again, you consider 12 in cumulative frequency, first value 12, 28, 67, 123, 185, 260. Okay, our value is 225. So 225 lies at 260 because the above value is 125, 185. So 185 up to 185 observations, that lies in that particular class interval. But 225, we want 225th observation. So 225th observation is lies at 260. So across that particular 260, the class interval is 1050 to 1100. The class interval, month wages. Okay, so 1050 to 1100, and frequency is 75, and cumulative frequency is 260. So we need that class intervals. Okay, so L plus 3n by 4 minus PCF by F into I. So you just apply that particular values. L means 1050 plus 3n by 4, 225 minus preceded cumulative frequency. For 260, the above value is 185 in the cumulative frequency table. Okay, so 185 by frequency. So 75 is the frequency across the 260 value in the cumulative frequency, right? So frequency is 75 into 50. Okay, so you will get q3. Now we want quartile deviation. For quartile deviation, the value is q3 minus q1 by 2. So q3 value is 1076 minus 0.67 minus q1 957.14 by 2. You will get qd. Okay, quartile deviation. So for quartile deviation, first you have to calculate q1, then q3, and the formula is q3 minus q1 by 2. Okay, and mean deviation or average deviation. So how to calculate a mean deviation or average deviation? For calculating average deviation, AD, the formula is sigma x minus x bar by n. Okay, so here how to calculate x minus x bar by n? So this is the given problem data. For 100 companies, they given sales, okay, in thousands. For 40,000 to 50,000, how many companies are getting 40,000 to 50,000 per day? Number of days, 10 days. 50 to 60,000, 15 days. It taking 15 days. 60 to 70,000, 25 days. Okay, 70 to 80,000, it is taking 30 days. 80 to 90, 12 days. 90 to 100, 8 days. Okay, so what is the compute the average deviation? Okay, so you just take the above table, sales in thousand and number of days, frequency in that particular thing, x, midpoint. Midpoint means 40 to 50, 45, 50 to 60, 55, 60 to 70, 65, 70 to 80, 75, 80 to 90, 85, and 90 to 100, 95. So we have sales, x point, midpoint, and number of days. Number of days is already given in the problem. It is f. Okay, now calculate fx. That means number of days into x. 5 into 45, 225. 15 into 55, 825. 25 into 65, 1625. 30 into 75, 2250. 20 into 85, 1700. 5 into 95, 475. Now we have fx. and calculate x minus x bar. For calculating x minus x bar, first we have to know x bar. So average x bar is equal to sigma fx by n. So we have fx, right? So fx means 25, sorry, 225, 825 in the table. Fx column 225, 825, 1625, 2250, 1700, 475. So you sum up all the values. Sigma fx. Sigma fx is 1700. So x bar is equal to sigma fx by n. So how you will get n? N means number of, that means sum of frequency, number of days. Frequency is number of days. 5 plus 15 plus 25 plus 30 plus 20 plus 5. N is equal to 100. So 1700 by 100 is equal to 71. So x bar is 71. Now calculate x minus x bar sigma. Sorry. Um, so x minus x bar. X minus x bar. X means midpoint. X bar means 71. So 45 minus 71 minus 26, but you are taking positive values only. Okay. So 26. Again 55 minus 71, 16. 65 minus 71, 6. 75 minus 71, 4. 85 minus 71, 14. 95 minus 71, 24. Now calculate f into sigma x minus x bar. Okay. So here we have x minus x bar values 26, 16, 6, 4, 14 and 24. F values number of days 5, 15, 25, 30, 25. Okay. You just multiply each and every observation. F into x minus x bar. 5 into 26, 130. 15 into 16, 240. So like that, for every observation, you are calculating f into x minus x bar. Okay. If you sum up all the values, then you will get 1040. Now calculate AD, average deviation, is equal to sigma f into x minus x bar by n. So f means, okay, sigma f into x minus x bar means 1040. We calculated that from the table. F into x minus x bar. Sigma f into x minus x bar is 1040. So 1040 by n. N is 100. So 10.4. So that is the average deviation. And last one is standard deviation. So standard deviation is very, very important, and you can expect this particular problem in your examination. Okay. So for calculating standard deviation, we have several problems, several formulas. Sigma is equal to root over sigma fx square by n minus sigma fx by n whole square, or root over sigma fx square by n minus x bar whole square, or another formula is root over sigma f d square by n minus sigma f d by n whole square into I. Okay, here d is equal to x minus a by I, auxiliary point. So in last previous class, previous topic also, we discussed auxiliary point in the arithmetic mean. For calculating arithmetic mean, we used auxiliary point, right? So that particular method, if they ask you auxiliary point, so through auxiliary point calculate the standard deviation, then you can calculate this particular formula. Through this particular formula, you can calculate the standard deviation. Okay. So these are the formulas for calculating the standard deviation. And now you just see the problem. Okay. So this is the problem given, and for this particular problem we have to calculate the standard deviation. To understand the formula, the group data, consider the following data which related to the profits of 100 companies. So the for 100 companies the profits are given, and these are classified according to the profits in lakhs and number of companies. So 8 companies got the profit between 8 to 10 lakhs, and 12 companies got the profit between 10 to 12 lakhs, and 20 companies got the profit between 12 to 14 lakhs. Okay, so like that they have given the data. And now take the data profits. So 8 to 10, 10 to 12, 12 to 14, 14 to 16. So that particular data is given in the problem. And next you have to calculate the midpoint, x. So 8 to 10, midpoint is 9, 10 to 12, 11, 12 to 14, 13, 14 to 16, 15, 16 to 18, 17, 18 to 20, 19. And frequency that is given in the problem 8, 12, 20, 30, 20 and 10. And D, you have to calculate the D. D means x minus a by I. So here A, how you will calculate the A value? From the midpoint, you will calculate the A value. So that is lies in the middle of the value, middle of the midpoint. So here we have even number. Okay. So here observations. How many observations are there? 6 observations are there. So 6 observations means it is an even point. So even series, in even series, there is no midpoint. So mid value, right? So for mid value, for considering mid value, you have to take the middle points. In middle points, x value, in x value 15. Okay, you just see 16 observations, 9, 11, 13, 15, 17 and 19 in the middle point row. Okay, so it is an even series, 6 observations are there, so there is no middle value. So that's why you have to take either 13 or 15. We are taking 15 because this is the greater value. We will get a good that means we will get a good number of values for calculation purpose. We are taking the greater value as the auxiliary point. Okay, so you can take 13 also, but it will complicate some of the that means calculations if you take less value. That's why we are taking the 15 greater value in this particular series. Okay, so D is equal to x minus 15 by 2. So x means 9 minus 15 by 2. So 9 minus 15, 6 by 2. So minus 3. 11 minus 15. So 4 by 2. 2. 13 minus 15. 2 by 2 minus 1. Okay, so like that you have to calculate the D values. Once you calculate the D values, then you have to calculate F into D. So F means 8. 8 into minus 3, minus 24. So you have to consider the negative values also, FD. So once calculate the FD values, you have to calculate the sigma FD. Once you calculated the sigma FD, then you have to go for F into D square. So F into D square means here F value 8, D value minus 3. So minus 3 means minus 3 whole square. So 3 into 3, 9. So 8 into 9. So 8 into 9, 72. So that is the FD square. Again 12 into 2 square, 4. So 12 into 4, 48. 20 into 1 square, 20. 30 into 0 square, so 0. 20 into 1 square, 20. 10 into 2 square, so 40. So F into D square, sigma FD square is equal to 200. Now apply these values in the formula. Sigma is equal to root over sigma FD square by N minus sigma FD by N whole square into I. So root over to sigma FD square. Sigma FD square means 200 by N 100 minus sigma FD minus 28 by 100 by N means by 100 whole square into 2. Okay, if you calculate that series or values, then you will get 2.7724. So like that you have to calculate the standard deviation. So this is the calculation for standard deviation. Next is coefficient of variation. So how to calculate the coefficient of variation? So actually, what is coefficient of variation? This measure is simply the ratio of standard deviation to mean expressed in percentage. So we already know what is mean and what is standard deviation. Now, if you divide this particular standard deviation by mean, then you will get the coefficient of variation. Okay. So coefficient of variation is equal to CV is equal to sigma. Sigma is the symbol of standard deviation. Sigma by x square average. So sigma by x square into 100. Okay. So for calculating this, again you just consider this particular problem. The consider the following data which related to the mean daily sales and standard deviation for 4 regions. Okay, for 4 regions they have given me daily sales and standard deviation. Okay, so determine which region is most consistent in terms of daily sales. We shall compute the coefficient of variation. Suppose if you want more consistent, okay, so what is the more consistent region, then you have to calculate the coefficient of variation, because if that particular region has a less coefficient of variation, then you can say this particular region is more consistent. That means repeatedly they are giving a maximum sales or constant sales, constant performance. Okay, if you want a consistency, if you want to measure the consistency, then you have to calculate the coefficient of variation, and whatever region has the less coefficient of variation, that particular region is more consistent. Okay, so for that first you have to calculate the coefficient of variation. So how we calculate the coefficient of variation? The sigma, the that means the problem itself is sigma by x bar into 100. So we know for first region the mean daily sales means x bar average, and standard deviation sigma. So for first region average is 86 and standard deviation is 10.45. So CV1 means coefficient of variation for region 1, 10.45 by 86 into 100, 12.15. And for second region coefficient of variation is equal to, for second region the average is 45 and standard deviation is 5.86. So 5.86 by 45 into 100, 13.02. For third region 72 and 72. So again you have to calculate this particular thing, 13.25. And next one for fourth region 11.32 by 61. So 11.32 by 61 into 100, 18.56. Actually, for region 3, there is a printing mistake. Okay, the standard deviation is not 72, it is 9.54, and average is 72. So 9.54 by 72 into 100, that is 13.25. And CV4, it is a 11.32 by 61 into 100, 18.56. So now, as we already discussed, the value is less, the coefficient of variance value is less, automatically that is more consistent. So 12.15, 13.02, 13.25 and 18.56, the less value is 12.15. 12.15 was for first region. Okay, this value comes from first region, so that's why the coefficient of variance is minimum for region 1. Therefore that particular region is more consistent. Okay, so this is the calculation of coefficient of variation. Okay, so what is screwness? Okay, so screwness means it is nothing but lack of symmetry. So symmetry means the curve which has a midpoint at the center, and if that particular that means if you come down from that particular central point any either way, the values has to be same. Okay, that type of curve is called symmetric. Okay, if that particular symmetric nature is lack in that particular graph, then automatically you can say that particular graph is screwed. Okay, so in next class we will discuss about screwness. So thanks for your patience listening. Thank you.
Sir, I want my register.